Your landing page is really shitty, and while you have ideas on how to improve it, it's a risk to roll changes out before knowing if they perform better. In this video, I'm going to show you how you can be confident that your product or landing page changes actually make a difference. We've all been there. You have a landing page or product feature that isn't performing well, and someone on your team says, "Hey, I bet it would perform better if we made some changes." You make the changes, push them out, and don't see any difference in your conversion for a couple days. After a few days, maybe it starts performing better. But wait, you also started a new ad campaign. Was the campaign the reason for the higher conversion or the page changes? With changes in traffic, ads, day of week, seasonality, and so many other factors, it's hard to determine what caused a change. In order to isolate and actually determine if a change you made is what caused an improvement, you can run what's called an A/B test. An A/B test is where we serve two versions of a page or feature to our audience, randomly assigning users to one version or the other, and then using statistical analysis to determine which one was better. An A/B test is often also called an experiment, so I'll use both words throughout the video. There are two stages of running an A/B test that I'm going to walk you through today: the design stage and the analysis stage. During design, our primary concern is figuring out how long we need to run the test. During analysis, our goal is to figure out what the data is telling us. Was version A better or version B, or are they the same? I run a community called Delivering Growth for people who are focused on growing their product or website. If you want to learn more about how to grow your user base and optimize your product or website with growth, experimentation, and A/B testing techniques, then this is the community for you. I'm Javed. I helped lead the 45-person growth team at Postman, the world's largest API developer tool with tens of millions of users, where I helped scale the company from 60 to 100 million in revenue. Now I help other teams do the same thing in the Delivering Growth community. We have a classroom with in-depth courses on how to design, implement, and analyze experiments. We have weekly calls where we walk through different topics on growth and experimentation, and we have a community forum where you can ask questions and I'll answer them directly. It's totally free to join, and I'll put a link in the description below for you. Before we run the A/B test, we want to know how long it needs to run and how much data we need to collect. And after we've collected our data, we need to analyze and see which version of our change performed better. To help answer these questions, I've released a number of calculators on the user-growth.com website that you can use. I'm going to walk through these and keep the descriptions at a pretty high level, avoiding too much mathematical or technical jargon. In each calculator, there's a detailed explanation of how the calculator works and when to use it. Before we dive into the calculators, I'm going to show you how to use the A/B test simulator that demonstrates how an A/B test works. Then I'll walk through several calculators that you can use to design and analyze your experiments. Let's dive in. The A/B test simulator helps you understand how A/B tests actually work in practice. Here's why this matters. When you run a real A/B test, you have to wait weeks or months to see the result. But with the simulator, you can see instantly what happens when you run a test with different conversion rates and sample sizes. This is really useful because it helps you understand why some tests need more data than others and how random chance can affect your results, even when you're doing everything right. To use it, you simply enter your control conversion rate, your variant conversion rate, and how many users you want to simulate. Then you click to run the simulation, and it shows you what might happen if you ran that test. After you run the simulation, you'll see charts showing your conversion rates, p-values, and confidence intervals over time. The p-value chart helps you know if your test is conclusive. It tells you how confident you can be that one version is actually better than the other versus just being different due to random chance. The confidence interval chart shows you a range of values where the true conversion rate likely falls. It tells you how sure you can be about your results. A narrower interval means you're more certain, while a wider interval means there's more uncertainty. These charts update as your test collects more data, so you can see how your confidence in the results changes over time. A great way to use this simulator is during the design phase after you've calculated your estimated sample size for an experiment, and then you plug it in here and run it multiple times. If you intermittently see the experiment be significant and non-significant after the simulation runs, then potentially you need to run the test longer. Sample size calculator. Before you run an A/B test, you need to know how many users you need to collect data from. That's what the sample size calculator helps you find out. Here's why it matters. If you don't collect enough data, You might think your changes made a difference when it was just random chance, or you might miss a real improvement because you don't have enough users to detect it. The calculator tells you how many users you need per variant to confidently detect a meaningful difference. To use it, you enter your baseline conversion rate. That's your current conversion rate before making any changes. Then you enter the minimum detectable effect, which is the smallest improvement you care about detecting. For example, if your current rate is 2% and you want to detect if it goes up to 3%, your minimum detectable effect would be 1 percentage point. The calculator will tell you how many users you need per variant. Remember, you need this many for your control and your variant, so double that number to get your total sample size needed. P-value calculator. Once you've run your A/B test and collected data, you need to figure out if your results are meaningful or just due to random chance. That's where the p-value calculator comes in. The p-value tells you how confident you can be that one version is actually better than the other. A low p-value means you can be pretty confident there's a real difference. A high p-value means the difference you're seeing could easily be explained by random chance. To use this calculator, you enter how many conversions and visitors you had for your control group and how many conversions and visitors you had for your variant group. The calculator will then tell you the p-value, which helps you know if your test is conclusive. Think of it like this. If the p-value is below 0.05, that typically means you can be 95% confident that the difference is real, not just random noise. Confidence interval calculator. After running your A/B test, you want to know not just whether one version is better, but also what range of values the conversion rate likely falls into. That's what a confidence interval shows you. A confidence interval gives you a range, like between 2.5 and 3.5, where you can be confident the true conversion rate actually is. A narrower interval means you're more certain about the result. A wider interval means there's more uncertainty. To use this calculator, you enter your conversion counts and visitor counts for both your control and variant groups. The calculator will show you confidence intervals for each, which helps you understand not just which is better, but how much better and how certain you can be about that difference. This is really useful because it gives you a sense of the precision of your results. You can see if you have a tight estimate or if there's still a lot of uncertainty. P-value and confidence interval over time. When you're running an A/B test, you don't just want to know the final result. You want to see how the confidence in the results changes as you collect more data over time. That's what this calculator shows you. This tool lets you input your test data day by day, and it creates charts showing how the p-value and confidence intervals evolve as your test runs. You can see if your test is getting more conclusive over time or if you need to keep collecting data. To use it, you add data for each day of your test, how many conversions and visitors you had for both control and variant on each day. Then you click to plot the results and see how your p-value and confidence intervals change over time. This is really helpful because you can see if your test is trending towards significance or if the results are still too uncertain to make a decision. It helps you know whether you have enough data to confidently call a winner. Duration calculator. Once you know how many visitors you need for your test, you need to figure out how long it'll take to collect the data given your daily traffic. That's what the duration estimator calculator is for. This is important because you want to plan ahead. You need to know if your test will take a few days, a few weeks, or even longer to complete. This helps you set expectations and plan your work accordingly. To use this calculator, you enter your daily traffic, how many users visit the page or feature you're testing each day. Then you enter how many variants you're testing. Typically that's 2 for an A/B test, 1 control and 1 variant. Finally, you enter the sample size per variant that you got from the sample size calculator. The calculator will then tell you how many days your test needs to run to collect enough data. This gives you a realistic timeline for when you can expect to have results. How much longer calculator? If you're running a test and you've reached your predetermined sample size from your design phase, but your results are still inconclusive, you may be wondering if you should let it run longer or just call the test inconclusive. That's what this calculator helps you figure out. This is really useful because you don't want to stop a test too early and make a decision based on incomplete data, but you also don't want to run it longer than necessary. To use this calculator, you enter how many conversions and visitors you've collected so far for both your control and variant groups. You also enter your total daily traffic, which helps the calculator understand how quickly you're collecting the data. The calculator will then tell you how much longer you need to run the test to reach statistical significance based on your current results and traffic patterns. This helps you know if you're close to having conclusive results or if you still need to be patient. With these calculators, you're now armed with everything you need to know to design and analyze your A/B tests with confidence. You can use the simulator to understand how the tests work in practice, the sample size calculator to figure out how much data you need, and the duration estimator to plan your timeline. Then, when your test is running, you can use the p-value and confidence interval calculators to analyze your results and see if they're conclusive. All of these calculators are available for free on user-growth.com, and I'll put links to all of them in the description below. Now you can run A/B tests, knowing exactly how much data you need, how long it'll take to run, and whether the results are meaningful. No more guessing, no more wondering if you have enough data. Go ahead and start testing with confidence.